Okay, so I did mention that I might find another way of doing question 4. I've just had a little play around with that question. So it's a rock is dropped down the well. It is, I know the well is 12 meters deep, and we know the acceleration, because it is dropped, is 9.8 meters per second. And we want to find out, so we're finding the velocity at x equals 12. So essentially, if we list all of this information, there's no mention of t. So we can use a different way to integrate rather than bringing t into it. Let's keep everything in terms of x and v. Now the other point we also know is that because the rock is dropped, the velocity equals 0 at x equals 0. So for acceleration equal to 9.8, instead of calling that dv dt and having multiple steps of integration, I'm going to actually use this version of acceleration and write that. So now when I anti-differentiate, I get a half v squared is the integral of 9.8 in terms of x. So I'm keeping all my variables in terms of x. And I also initially know when x equals 0, then the velocity equals 0. Now because velocity is not just a v on this side, I can't just substitute in just the 0. I have to use the whole equation. And I want to find out what it's equal to when x is 12. So if I type that into my calculator, I get 588 over 5, I think it was. I've already done this question, so I'm just writing down the answers. So we get a half v squared equals 588 over 5. Then double it, which is going to give me 1162 on 5. 1176 on 5. Sorry, my by hand maths was wrong there. And then take the square root, and we only need the positive square root because we're assuming the velocity is only increasing. It's not going to be a negative velocity. That gives me approximately 15.3362. So the velocity is 15.3362 meters per second. I then have to convert it to kilometers per hour. And the way I convert it to kilometers per hour is I multiply by 18 over 5. So that's the rule in your book if you look that one up. And when we do that, it is approximately 55 kilometers per hour, which gives the answer of C. So that's the quickest way of doing it, but the understanding involved to run through the question that way is a little bit more involved.